Okay, so on the first problem, where it wants the least common denominator, that's all we have to identify. We don't have to actually rewrite the fractions, getting the least common denominator and stuff. We just have to identify what it would be. So anytime you want to deal with fractions and you want to know common denominators, you have to make sure things are in factored form. So my x squared plus x minus 20, if I put that in factored form, I would x factor that out. So I would need to come up with two things that multiply to give me negative 20, that add to give me a positive 1. And what would that be? The 5 and 4 are good, but I would make the 5 positive because it has to add to be a positive 1. So if I make the 4 negative, the 5 positive, it does multiply to give negative 20 and would add to give the positive 1. So as factors, that's going to be x plus 5 and x minus 4. Now when you compare that with the other denominators, you see that they already had the x plus 5 and the x minus 4. So when you identify the common denominator, you take the pieces that they have in common, and if there was any other non-common piece, you'd have to add that to it. So in this case, the common denominator is only going to be the x plus 5 and the x minus 4. There's nothing else. But if I had another denominator of x plus 3, I'd have to put that too. So on that one, our answer is just this right here. Okay, so on number 2, where it wants us to solve the equation, I have to do similar to what I did in number 1. I need to make sure my denominators are factored. Once it's factored, then I can multiply by what the common denominator would be, and all my fractions will cancel. So when I factor my denominator, the x squared minus 25, what kind of factoring do I do? Difference of squares is perfect. So what two same numbers multiply to give the 25? Good. So I'll do one with an x plus 5 and the other one with an x minus 5. So now looking at my denominators, the common denominator would be the x plus 5 and the x minus 5. So I can now go and multiply each fraction by x plus 5 times x minus 5. So when I multiply to the first fraction, the x plus 5 right here would cancel out with this blue x plus 5. So then what I'm left with is my red x minus 5 that gets times to the negative 3. So I'll get negative 3 times x minus 5. Now when I distribute over to the next fraction, my red x minus 5 will cancel out the blue x minus 5. So then I have the x plus 5 to still multiply to the 8. And then when I distribute to the last fraction, my x plus 5 cancels my x plus 5, my x minus 5 cancels my x minus 5. So the only thing I'm left with is my numerator, which is the 2x plus 5. Now once I get to that point, all I have to do is distribute and then combine like terms and solve. So distributing the negative 3 in, I'll get negative 3x, and then negative 3 times negative 5 is positive 15. And then distributing in the 8, I will get 8x, and then 5 times 8 is 40, equals 2x plus 5. Now combining like terms, I can combine the negative 3x with the 8x. So negative 3 plus 8, that's going to give me a 5x. And then I can combine the 15 with the 40. So 15 plus 40 is 55, equals 2x plus 5. And now I need my x's on the same side of the equation. So that 2x, I can subtract it over to get it over on the left-hand side with the 5x. So 5x minus 2x gives me 3x. And then plus 55 equals 5. Now I want to isolate the 3x, so I want to move the 55 to the other side of the equation. So since it was a positive 55, I use the inverse operation, which is subtraction. So now 3x equals 5 minus 55, which is negative 50. And then my last step would be to divide by 3. So x equals negative 50 over 3. If you don't like fractions, you can type it in the calculator and put a decimal number, just as long as you have something equivalent to that. Okay, so on number 3, in order to solve this one, any ideas what we could do? Do what? I don't need to do anything with a common factor.
Did you square both the roots?
I do need to square both roots, but I don't want to do it yet because I can only square once on each side of the equation. Add, yeah, so I could add the root that has the minus on it to the other side of the equation, and then I can square, because you can only put a square once on both sides of the equation. So when I add it over, the only thing I'm going to change on that root that I'm adding over is the sign in front of it. I'm not going to change the sign of anything that's underneath the root. So you leave it as a positive x and a positive 8. You can't touch anything under it because it's like being protected by the root. So then I get root 4x plus 3 equals root x plus 8. And now we can go with Joel's suggestion where we can now square. So I'm going to square the left-hand side of the equation and square the right-hand side. So now a square and square root will cancel each other out. And then I'm left with 4x plus 3 equals x plus 8. Now I need to get my x's on the same side of the equation. So I am going to minus x. And minusing x is like minusing 1x, so I can put a 1 in front of it. So now 4x minus 1x is 3x. So 3x plus 3 equals 8. And then continue isolating the variable, so I will subtract 3. And then I get 3x equals 5, and then divide by 3. So my answer is 5/3. You could put the decimal if you wanted. Now, one thing to be careful of, when you square both sides of the equation, you do have the potential to introduce what are called extraneous solutions. Those are false solutions. So we really should take our answer we got, plug it back into the original, and make sure our answer really comes out as 0. If it doesn't, then the answer we got is a false solution, and we have to cross it out, and we would have no solution. So my 5/3? I'm going to go and just type it into the original. So square root of 4 times 5/3 plus 3, and then I arrow out of the root before I minus off the other root, and then type in the 5/3 plus 8. And it does tell me 0, so I know my answer's good. But you do need to double check any answers you get when you square both sides of the equation, because it could be that an answer really was not your solution. And I probably should have mentioned something similar on the previous problem right here, where we had the fractions. If my answer had come out to be a positive 5 or a negative 5, because if I put a negative 5, negative x for the x plus 5, if I plugged in a negative 5, if I got a 0 here, or if I got a positive 5, then 5 minus 5 would have been 0. If I would have got an answer that would have made the denominator equal to 0, then I would have to discard that answer too. But in this case, I got negative 50/3, which would not make my denominator equal 0, so that one was okay.
Can we interrupt for a second?
Uh-huh.
Is anyone interested in doing the blood draw?
Okay, so on number 4, when I want to solve, I am going to have to square like I did on the previous problem, but before you do any squaring, you always want to make sure your root is isolated first. So you don't want anything being added or times, excuse me, added or times to the root. So I need to start by moving the 9 to the other side of the equation first. So just always make sure the root is the only thing on the left-hand side of the equation before you square. So I would need to start by subtracting the 9. So then I get root x over 4 equals 11. Now that the root is completely isolated, now I can go through and do the same steps that we did on the previous problem, where we square both sides of the equation. So the square will cancel out the square root, so I get x over 4 equals 11 squared, which is 121. And then how am I going to get the 4 off of the denominator? Good. Okay, so times to both sides. So then I get x equals 121 times 4, so 484. And again, because I squared both sides of the equation, my answer has the potential to be a false solution. So to quickly check it, I'm just going to type the original problem in, replacing the x with a 484. And then make sure I arrow out of the root before I add the 9. And I do get the answer of 20. But if my calculator had come out and told me the answer was negative 20, then I would say, oh, it's a false solution, and then I would have had no solution. So again, just double check all of your answers and make sure they really work, because you could have false solutions. Okay, so this problem's kind of nice because the roots are already isolated and they're already on the opposite sides of the equations. So I can just immediately go and square both sides of the equation. So the square and square roots will cancel. So x squared plus 2x equals 24. In this case, normally we do factor, and that will be one of my steps, but I don't want to factor out an x yet because it's always supposed to equal 0 when you start the factoring. So, yeah, correct. So after I subtract 24, then I would go through the factoring techniques. So x squared plus 2x minus 24 equals 0. Okay, so I'm just going to put the little steps that I kept putting up in the notes. So anytime we need to factor, what should be the first step? Yes, GCF is correct. So greatest common factor. In this case, there is no GCF, so you don't have to worry about it. Step number 2, what was our step number 2? Good. So x factor, or what was the other common type of factoring? Difference of squares. And we could do the quadratic formula, so I'll put that one down also. So I'll do difference of squares. You could do the quadratic formula, and we will have to do the quadratic formula on at least one of the problems today. This one will factor out nice, but we'll come across another one that won't. So the quadratic formula always works, but sometimes it's a lot faster just x factoring it than going through the quadratic formula. So I always try x factoring first. Okay, and then after you've factored it, if you could, x factoring or difference of squares, what would be the next step? Well, after we had x factored it, what do you do with those factors? Solve for 0. You set each factor that contains an x equal to 0 and solve. Okay, so going through this process, when I x factor it, 1 times negative 24 is negative 24. The b value was 2. So what are two things that multiply to give negative 24 that add to give 2?
4 and 6.
Okay, so 4 and 6. And yes, you are correct, it will be negative. So negative 4 times 6 is negative 24. Negative 4 plus 6 is 2. And then the next step would be to divide by the a value, which was 1, but it won't change the answer. So as factors, I get x minus 4 times x plus 6. And then this is where I now set each of those factors equal to 0. So that's step 3, set them equal to 0 and solve. So I add 4. And then on this one, I minus 6. So I get that x equals 4 and x equals negative 6. Now, since I did square both sides of the equation, it is possible that one of these would be extraneous. I'm not going to go through the time checking it because we did check it in my previous class and both answers worked. Okay, but you would want to, on your test, make sure your solutions really are your solutions, because if one worked, like if 4 worked and negative 6 didn't, the only answer you should put would be the 4. But in this case, both of them would work if you went and checked. Okay, so on 6, we're given this equation, and it says one root is 4. What are the other two roots? So our highest power, since it was a 3, we know we should have a total of 3 roots. Where they told us one of the roots was 4, what would I do with that 4 to help me find the other 2 roots? Okay, so doing synthetic division with the root we know. I'll have the 4 here, and then you have to make sure all your powers are accounted for. So I have an x cubed, an x squared, an x to the first, and a constant. So I don't have to put a 0 in for anything, but I do need to put a 1 in front of the x cubed. So I use the coefficients of 1, negative 6, 18, negative 40. And then since they did say that 4 was a root, I would expect to get a 0 in my remaindered spot. So I'm going to go ahead and drop the 1. 4 times 1 is 4. Negative 6 plus 4 is negative 2. 4 times negative 2 is negative 8. 18 plus negative 8 is 10. 4 times 10 is 40. Negative 40 plus 40 is 0. Now, unfortunately, they didn't tell me any more of the roots. They only gave me that one. So, okay, good. But before I could try x factoring, I first have to write it out as an equation. So I would need to, how am I going to write the 1, negative 2, and the 10 as an equation?
Squared minus 2x plus 10.
Perfect. So you drop the power once each time you do synthetic division. Okay, so now I could go through the same steps that I had listed out, 1, 2, 3 on the previous page. Check for a GCF, but there was no GCF. Then I could try x factoring it. So if I tried x factoring it, I would do 1 times 10, which is 10. Try to multiply to get negative 2. Okay, yeah, there's nothing that will multiply to give 10 to add to give negative 2. So this is where I was saying you would have to, on a problem, do the quadratic formula, which is another thing that we had listed as step 2 that we could do. So the quadratic formula always works. X factoring doesn't always work. So then you just think of that song. The quadratic formula is negative b plus or minus the square root b squared minus 4ac all over 2a.
I don't like that.
If it helps you remember it, though. Okay, so then we just list out a, b, and c and plug the numbers into the appropriate place. So my a is 1, my b is negative 2, and my c is 10. So I say x equals, now when it said, the formula says negative b, that means you take whatever your b is and you have to switch it to the opposite sign. So my b was a negative 2. If I put a negative in front of a negative 2, it would switch to a positive 2. So I'm going to do positive 2 plus or minus the square root. Now the b that's under the root, you have to square it. So I'm going to take my b, which was negative 2, and put it in parentheses, and then put the square outside of the parentheses. Minus 4 times the a, which was 1, times the c, which was 10, all over 2 times the a, which was 1. So I'll get x equals 2 plus or minus something under the root, and then 2 times 1 is 2. So now in your calculator, do not type the square root in. Just start with the stuff underneath the square root. So do not put the square root in, just type in the parentheses negative 2 squared minus 4 times 1 times 10. And what do you get? Okay, so negative 36. If you had typed the square root into your calculator, you would have got an error in your calculator. That's why I told you not to type the square root in. Okay, now I have a negative under the root. What do we do to get a negative out of a root? Good. Okay, so we'll put an I on, change that to a positive and an I. And then to simplify the things under the roots, we factor. And if you can think of 2 things that multiply to get 36, okay, 6. So even though you could do, like, say, a 4 and a 9, if you can think of 2 same things that multiply to give that number, you can factor quicker. Because I have 2 of the same factors, I can just immediately group those together and pull it out. I don't have to continue factoring them down to 3s and 2s. I can group that together, pull it out, and then I won't have anything left under the root. So I have x equals 2 plus or minus 6i over 2. A common mistake I'll see some students try to do when there's the 36 under the root, I'll sometimes see students try to go 36 and divide by the 2 that's down here, but you're not allowed to do that because one's under a root and the other one isn't. But now that that 6i is not in a root anymore, I could now break this into 2 separate fractions and do 2 divided by 2 plus or minus 6i over 2, and I can just divide them each individually. So 2 divided by 2 is 1, and then 6i over 2 is 3i. So the question said, what are the other 2 roots? I now know what the other 2 roots are. That's really 2 of them. I would have 1 plus 3i, and the other root is 1 minus 3i. And then I have the original root of 4 that we were given at the beginning. So these are all of my 3 roots that I should have. And then this question didn't ask for factors, it just wanted the roots. Oh, now remember on your tests, they might use the word roots, but they might not have asked for roots. They might have asked for what other words might they have used? Okay, they might have said solutions. What was another word they could use? Zeros, good. And then there was one other word? Good. Now in this case, the x-intercepts, the imaginary answers aren't x-intercepts, only the 4 is the real answer. So the imaginary ones, we could still call them roots, solutions, or zeros. We just wouldn't call them x-intercepts. Okay, so this one says, if the roots of the equation are plus or minus 10i, then what are the factors? So when they have those roots listed as plus or minus 10i, that would be the same as them saying 10i, comma, negative 10i. So when you have the roots, what do you do to put them as factors? So for your factors, you just put an x and do the opposite of each root. So that first root that was a positive 10i, I put a minus 10i. And then my other factor, I again put an x, and then instead of the minus 10i, I switch the sign and put a positive 10i. Whoops. And that's all you have to do for factors. Now, a word of caution with factors, though, if I had a root of, say, 2/3, if they gave you a root of 2/3 and said write the factors, if there's a fraction, you actually do bottoms up. So the bottom would go up in front of the x, so it would be a 3x, but then you still have to switch the sign. So instead of a positive, it would be a negative. So if you do have a fraction, make sure you do bottoms up, but then still switch the sign. Okay, so on 8, we're again given roots, and now they ask us to find an equation that would have those roots. So the very first thing you want to do if you're given roots and you want an equation is you first want to write the factors. So I'm going to do the same thing I did in number 7. So as a factor, how would I make 4/3 as a factor?
3x minus 4.
Perfect, 3x minus 4. Flip the bottom up, the denominator up, so I'd get the 3x, and then the opposite of the positive 4 is a negative 4. Okay, what would the other factor be? Oh, but use the opposite sign.
X plus 2.
X plus 2. Okay, so these are our factors. Now, if it wants the equation, you have to have an equal sign or you don't have an equation. So I would just say like equals y. Now I have an equation, but I can guarantee on the test it won't want the equation to look like that. It would want those factors all FOILed together. So foiling the factors out, I'll do 3x minus 4 times x plus 2. So x times 3x is 3x squared. X times negative 4 is negative 4x. 2 times 3x is 6x. 2 times negative 4 is negative 8. So now my equation, I'll have 3x squared. I combine the 6x with the negative 4x, and that gives me a positive 2x, and then minus 8. So that would be what you would need to put as your equation.
You would need to do the x factor.
Okay, so number 9 just says, what are the potential number of turns that this equation could make? It's actually not 6, but what does 6 tell me?
2.
It's not 2.
1 less than the greatest. 1 less than 6.
Okay, 1 less than the greatest power. Okay, so to start with the 6, what does the 6 tell us?
Let's go.
What does the highest power always let us know?
Root.
Roots.
Zeros are
How many roots or how many zeros? We can use either word. Or how many x-intercepts you could have. So since my highest power is a 6, I know if I graph this, it has the potential to cross the x-axis 6 times. And then if I use that information about end behavior where we had like even power, odd power, positive or negative, if your highest power was even and the leading coefficient was positive, both ends of the graphs should go up. And then if I could only cross the x-axis in those 6 spots, if I had to connect from one end of the graph to the other without ever picking up my pencil, then I would have something looking like this. So then the number of turns, you can see I could turn 1, 2, 3, 4, 5. So you don't actually have to graph something out. You just have to know the highest power tells you your roots, your how many roots you should have. So then the potential number of turns is 1 less than that if you were to graph it out. Now, if you actually graph this equation in the calculator and actually look to see how many turns it had, it may not have 5 turns. It just had the potential to have up to 5 turns. So it could have 5 or less. So you don't want to look at the calculator and state how many it really had. We just want to know that anything that has a 6th power has the potential to have 1 less turn than the power. So the answer to this one is 5, 1 less than the highest power. Okay, so this one says use synthetic division to find the quotient. So when you do synthetic division, the top of the fraction is what you use to go inside your synthetic division bar. So you make sure all the powers are accounted for. So I have an x cubed, an x squared, an x to the first, and a constant. So I just use the coefficients, so the 1, the 3, the negative 4, and the 2. Now in this particular problem, do you guys know what number I'm going to put in front?
X minus 3.
But we only want to do a number. I don't want to put an x minus 3. It's just a single number. Instead of negative 3, if they give it to you in a fraction format, you set it equal to 0, so it's going to be positive 3. Because then that's in the same format as like roots or zeros. So when I did synthetic division before, they would always say, oh, 1 root is, and then they'd tell us what the number is, and we would use that number. But if it's in like a factored form, that's not in the same format as a root or 0. So you have to set it equal to 0 and solve. Now, they didn't tell us, so I will use 3, but they didn't say that 3 was a 0. But I do need to use 3 when I do synthetic division. Since we don't know that 3 is a 0, I don't have to get a 0 in my remainder spot on this one. You only have to get a 0 in the remainder spot if they tell you your number was a root or a 0. Okay, so doing synthetic division, I drop the 1. 3 times 1 is 3. 3 plus 3 is 6. 3 times 6 is 18. Negative 4 plus 18 is 14. 3 times 14 is 42. And then 2 plus 42 is 44. So it's fine that I didn't get a 0 there because they didn't tell us that was a 0. Okay, now I have to write this back as an equation. So what variable should be with the 1? Perfect, 1x squared. 6x. What am I going to do with the remainder? I don't want to put in equals. Yeah, we divide it. So that 44, I'll go plus 44, and then you put it over the original denominator, which was the x minus 3. So if there's a remainder, you have to make a fraction with that part only. So on number 11, it says, what is the relative maximum and the relative minimum? So relative maximums and relative minimums, those are the spots where the graph turns. So a relative maximum, you're looking on the graph to find the spot where the graph goes up, turns, and comes back down. And whatever that ordered pair is, that's a relative maximum. The relative minimum is the spot where the graph is going down, turns, and then goes back up, and then you're finding that ordered pair that's down below. So this is not one that I would do by hand. I would go to the graphing calculator and graph it, and then we use the second trace feature of the calculator to help us find where those max and mins are. So we just go y equals, and then type the equation in. Now, if your screen, when you hit graph, if your screen is like some sort of bad screen, like you can't really see anything, hit zoom and then 6, and that resets you to the negative 10 to 10, negative 10 to 10. So zoom 6 will fix whatever screen issue someone else gave you. Okay, now from here, to find my relative max and mins, I want to find this spot here and this spot here. So second trace, yep. So second, the trace button. So number 3 says I'm going to do a minimum, so I'll do number 3 first. So when I select number 3, I have to make sure I go to the left of the minimum. I've seen people do like second trace number 3 for minimum, but then they try to find it on the maximum, and then you just get like errors in the calculator. So I make sure I'm to the left of where the minimum is. I hit enter, I arrow over for right bound. So I arrow past the minimum, hit enter. I never guess, I just hit enter one more time. So it tells me 0.72 comma negative 0.72. Sorry, that should have been negative 7.2, not 0.72. Okay, so now that I have my minimum, now that I want to now find the maximum, I'll do second trace again, do number 4, and do the one that says max. Now it says left bound, so I have to move my cursor to the left of where the maximum is. Hit enter, then I move to the right of the maximum. Hit enter, and then enter one more time. And it tells me 1.38, comma 2.5. Sorry, that was negative 1.38, comma 2.5. Now, one thing to be careful of, it didn't happen on this problem, but sometimes you might get something like my y value where it says negative 2.5. Oh, I still wrote that down. It was a negative. Where I have that y value of negative 2.5. If at the end I saw an e negative 6 or something like that, that would be calculator error, meaning it was really supposed to be a 0. So you have to look at the entire decimal and see if at the end you have an e negative number, because if so, you need to be writing 0 as that number and not what you're actually seeing. Okay, so with horizontal asymptotes on number 12, that's where in the notes I had like 3 rules where we did top heavy, bottom heavy, powers equal. So we're just comparing the power on the top with the power on the bottom. So top heavy, and you might want to make sure you have these down. So top heavy, good, none was the answer. So no horizontal asymptote. If you don't have that already memorized, then you might want to make sure that's on your note card. Top heavy meaning if the power on the top of the fraction is bigger than the power on the bottom of the fraction. There's no horizontal asymptote. The next rule that we dealt with was bottom. Yep. What was the rule for bottom heavy? What was perfect? So y equals 0. Make sure you do put y equals 0 because on your test it has multiple choice. And one multiple choice answer might say y equals 0. One might say x equals 0. So if you know it's supposed to be a 0, but you don't know if it's an x or a y, then you're still stuck guessing. So make sure you know all horizontal asymptotes are always y equals. Vertical asymptotes are always x equals. Okay, then the third rule were powers equal. And what was the rule for powers equal? Yeah, we make a fraction. And on the notes, I put it as a over b. So the a was just their leading coefficients. They're the numbers in front of the variables with the highest power, not necessarily the ones that are written first in the fraction. You find the one with the highest power, and you're writing the numbers in front of those. So you guys quickly go through 12, A, B, C, and you list off what you think those answers are. Okay, so on A, 12A, you should have said that there was none because it was top heavy. The 7th power is bigger than the 4th power. On B, you should have said the horizontal asymptote was y equals 0 because it was bottom heavy. You had the higher power on the denominator. On C, that was powers equal. So you should have said y equals negative 4/5, not negative 4/3. So you're not going off of the first terms that were listed. You're going off of the highest power. So it should have been the negative 4 over the 5 because those were the terms in front of the ones with the highest power. Okay, so I'm going to put for 13, some rules on finding the vertical asymptotes. So the first rule to find a vertical asymptote is you want to make sure everything's factored. So to factor, we're going to go through the same steps we did before, where the first thing you do check for factoring are GCFs, greatest common factors. After you've checked for GCFs, yep, X factor. Good, difference of squares. Technically, I wouldn't do the quadratic formula on this one because to find vertical asymptotes, we need them listed as factors, and the quadratic formula gives us the solutions instead of the factors. But it is possible to actually, if you really wanted to, do the quadratic formula, get the solutions, and then write them as factors. Okay, so I'll stick on my list, though, with X factor and difference of squares. Then the third step for finding your vertical asymptotes, I will set them equal to 0, but that's the fourth step. Yeah, the cancel first. If you can cancel between the numerator and denominator, you need to do it. Yep. So cancel if possible, but it's not always possible. And then the fourth step, set. And when you set it equal to 0, you're only setting the denominator's factors equal to 0, not the numerator factors. Equal to 0 and solve. Now you're only going to set the factors on the denominator that contain a variable. So if you pulled out a GCF that was just a constant, like say 3, if that doesn't contain a variable, you're not going to set it equal to 0. So it's only the denominator factors that contain variables that get set equal to 0. Okay, so on A, they asked us to find the vertical asymptotes of negative 7x over x squared minus 49. See, yep, that is a difference of squares. So how would I factor that as a difference of squares? Okay, so 7 times 7 gives me 49. So then it's difference of squares. Good, x plus 7, x minus 7. Now, when I go into the step that says cancel if possible, I can't cancel because negative 7x is different than x minus 7. One's being times, the other one's being subtracted. So even though they have the same stuff there, they're not the same. So then I go on to step 4, which says set the denominator factors equal to 0 and solve. So I don't set the numerator equal to 0, just the denominator. So I add 7 minus 7. And so I get x equals negative 7 and positive 7. So it is possible to have more than one vertical asymptote. Notice I specifically put x equals because, again, on your test, there'll be multiple choice. And one option might say y equals negative 7 and 7. So again, make sure you're really clear that vertical asymptotes are always x equals, horizontal asymptotes are always y equals. So on B, that one's nice because B's already factored for us. So we get a skip steps 1 and 2 and start on step 3. Yes. Yep. We can cancel. What's my new numerator? Good, 1. Yep. Always keep a 1 if everything canceled out. Okay, so now I can set my denominator equal to 0. -2 is correct. Now, if you didn't do that cancel step, you would have had a 4 also, but that 4 isn't a vertical asymptote. That 4, if you looked at the graph, would have just been a hole in the graph. Okay, so that's why you have to cancel before you set the denominator equal to 0. Okay, on C, step number 1, checking for a GCF. There is no GCF. Yep, I can X factor that. So 1 times 6 is 6, the B value is 5. What multiplies to give 6? That adds to give 5. Okay, 2 and 3, both positive. So now I have x plus 2 times x plus 3. Okay, step 3 would say cancel if you can. Yeah, but we can't, yep. So then I set the denominator factors equal to 0 and solve. So I'll minus the 2 and minus the 3. Yep, -2, -3 are my vertical asymptotes. Okay, number 14 wants us to determine the domain and range. If I wanted the domain and range of this, honestly, I would go and graph it on the calculator, look on the calculator, and help me to determine the domain and range. Did I write down the wrong one? No. Oh, sorry, I wrote down 15's graph. Okay, let me asymptote is. Yeah. So when I graph it in the calculator, I will have 1 divided by x minus 2. Okay, so then using our knowledge of the asymptotes that we just barely went through, since if I set the denominator equal to 0, I would get a vertical asymptote at 0, so I'm expecting a vertical asymptote right there. And then what would the horizontal asymptote be? Is this top heavy, bottom heavy, or powers equal? Not powers equal because I don't have a variable on the top of the fraction, so that would be a 0 power on the top. So on the top, that would be like x to the 0, and on the bottom, it's like x to the first. Bottom heavy. So on our bottom heavy, it said that it should have been 0, but that minus 2 right there, that's a vertical shift. It took the graph and shifted everything down 2, so it should have been at 2, but then it shifted it down 2. So I would expect a horizontal asymptote down at -2. So now when I do domain, I get on the portion of the graph that lets me go furthest to the left. So on this section here, how far leftward can I go? Good. So we'll go -infinity. And then now on that section of the graph, how far rightward can I go? Good. And at 0, am I going to do a bracket or parenthesis? Parenthesis. I heard both brackets and parentheses going on. I know for sure it needs to be a parenthesis because if I went to the table and typed in the x value of 0, I'm going to get error because that's where my vertical asymptote was. The graph is just getting close but doesn't reach it. So make sure on your asymptotes that you're using parentheses. Then I go union. Then I jump over to the next section of the graph and I go leftward. And how far leftward is it going?
0.
Good. So 0 to positive infinity. Now when I do range, I'm talking about the y values. So I get on the part of the graph that goes the furthest down, which is the section over to the left. And how far down can I go?
Infinity.
Good. And now how far upward can I go on that section? Good, -2 where my asymptote was. Again, I'm going to do a parenthesis. And then union, I jump onto the other section of the graph. I can see it's going down to the -2 and up to infinity. Okay. So again, if it asks you to do domain and range, just type it into your calculator to see what the graph is. And just be aware that you have some asymptotes there, so you just kind of have to determine where those asymptotes would be so that you get the correct domain and range. You expect usually to see your vertical asymptote in your domain and your horizontal asymptote in your range. There are some exceptions to seeing the horizontal asymptote in the range, but for the most part, that's what you guys should be seeing. Okay, so 15 wants us to graph. So I'm going to do most of this by hand. So if I want to graph a rational function, I again need to start by knowing where my vertical and horizontal asymptotes are. So starting with the horizontal asymptote, is this top heavy, bottom heavy, or powers equal? Good. So if it's powers equal, we do the ratio of the leading coefficients. Good. Yep, 1 over 1 is 1. Okay, then the vertical asymptotes. Nice thing is if I went through all those steps I showed for the vertical asymptotes first, like factor, GCF, X factor, I don't have to worry about that because I can't factor this problem. So I get to start on step 3, which says cancel if possible. Can I cancel? I can't cancel, I can't go -4 divide by 2 because once something has a plus or a minus sign, you have to treat that as an entire factor. So it's all of that or none of it. So I can't cancel anything either. Yeah, so on step 4, set it equal to 0, and I'm only setting the denominator equal to 0. Yeah, x equals -2 is my vertical asymptote. So then when I graph, that's going to be the very first thing I graph, my horizontal and vertical asymptote. So my horizontal, I go to where y equals 1 and just draw on a dotted line. For my vertical asymptote, I go to where x is -2 and draw in a vertical line. Now the next thing I want to do is I want to do a table. The x values I pick for the table, I'm just going to go to where my vertical asymptote is and pick x values to the left of it. So since it's at -2, x values to the left would be like -3 and -4. And then I pick x values to the right of my vertical asymptote, so like maybe -1 and 0. Now if I really wanted to, I could type those in myself and get the answers, or I could use the table feature on the calculator, and that's what I'm going to do. Now if you do use the table feature on your calculator, you have to make sure you put your whole numerator in parentheses, then divide, then put your denominator in parentheses. If you don't use parentheses, you're going to get the wrong answer. So make sure you used your parentheses. Then I can hit second table, and my points are already there, except I need the -3. So now graphing it, I'm going to graph -3, 7. So it's going to be up here, and then -4, 4. Now since both those points are above my horizontal asymptote, and I know I need to approach asymptotes, I would expect a graph looking something like this. Make sure not to go through your vertical asymptote and don't go through your horizontal asymptote. Okay, now I'm going to graph my -1, -5. And then my 0, -2. And then I also have 1 there, so I'll graph 1, -1. Now again, I'm going to connect through those points, approaching my asymptotes. Like that. Okay, so now that I have that, it then asks what is the domain, range, increase, and decreasing intervals. So my domain, same as what I did on the previous problem, I get on the section of the graph that lets me go furthest to the left. Oh, and by the way, I'm going to hit graph real quick on the calculator just to verify that my graph looks accurate. And that right there looks pretty similar to what I graphed without peeking at the calculator. Okay, so now to do my domain, you get on the section of the graph that lets you go furthest left. We can go left to -infinity. How far rightward can we go?
-2.
Good, -2. Bracket or parenthesis?
Parentheses.
Good. And then union, and then on the other section, how far leftward can we go? Oh, but -2. So -2 to infinity. Okay, and then range, we now start talking about downward movement. So on the section of the graph that lets us go down, well, we have to start on the section that lets us go down the furthest. So I actually want to be on the right-hand section. So that lets us go -infinity, yep. And then how high up can we go? Good. And then union, and then the other section, the left-hand section, lets us go down to 1 and then up to infinity. Okay, now it also asks about the increasing intervals and decreasing intervals. So when it talks about increasing and decreasing, you're talking about movement from left to right. So from left to right, where is the graph increasing? From left to right, where is the graph decreasing? On this one, what is it doing? And so it's actually always increasing. Yeah, we won't have a decreasing interval for it because from left to right, the graph never is going downward. So starting on the section that's furthest to the left, On that section, we're stating the x values. We're saying on what x values is it increasing. So the x value is from negative infinity until as you approach that asymptote again, which is at negative 2. Yeah, basically the domain again. So negative infinity to negative 2. The only difference is on the domain, where I put a union, technically on increasing and decreasing instead of union, I'm just going to go a comma, because technically when I go from the left graph to the right graph, on the left graph I was up really high, and then I have to jump down here to get to the other one. So technically at the negative 2, it wasn't increasing or decreasing. I had to drop my values. So I have lower values now, but they're still going to be increasing. So I just did a comma instead. But then it's still the domain values of negative 2 to infinity. And on the answer key, they might put a union on the test or whatever, but I'm just going to put a comma because technically I do now have some lower y values than my original one. Okay, and then decreasing, the graph never dropped, so that would be none. You don't have to have a decreasing interval. Okay, 16, this one also asks us to graph. Now, unfortunately, this one we can't graph completely by hand because I could factor out a GCF of 2, but then my remaining result, if I did factor out the 2, I still have an x cubed. And so since that's an x cubed, I wouldn't be able to do like x factoring or difference of squares. I can't do the quadratic formula because the quadratic formula is a second power. So I can't work that one out by hand. So this one I have to do in the calculator, like we did in the 5.4. We had a section where we used the calculator only to graph. So I would go to y equals and just type it in. And then to make sure I get my graph done accurately, I'm going to be using that second trace option again. I'll do second trace numbers 1, 2, 3, and 4 because that gives me basically all the key features I need to have an accurate graph. So with the second trace, option number 1, which will say value, that one will let me know what my y-intercept is. So when you do that one, the calculator will say x equals, and you just type in a 0 and you hit enter. And then when I do number 2, that one says zeros. What was another word for zeros? X-intercepts. Remember we had zeros, roots, x-intercepts, solutions. So x-intercepts, that's the key word that I wanted. So when I do the zeros, I'll really be finding my x-intercepts. And then number 3 will say minimums. That will be letting you find the places on the graph where the graph went down, curved, and went back up, and you're finding that low-ordered pair. And then when you do number 4, that one says max. That one you'll be finding the spot where the graph curves and goes up, and you'll be finding that high-ordered pair. So I want to find all 4 of those, and then once I know those, use that to graph. So starting with number 1, I'll go second trace, number 1, which is value. Notice it says x equals, I just type in 0. So it says 0, 2. So I now know I have a y-intercept at 0, 2. I did number 1, value. And then I typed in the x value of 0. Okay, then I'm going to go second trace, number 2 for zeros. Now when I do zeros, I'm going to have to do this one 3 times because I can see the graph is crossing the x-axis at 3 different times. So I need to find all 3 x-intercepts. So I'm going to start with the one furthest to the left. So it says left bound. So I just move my cursor to the left of my furthest left 0, hit enter. And then it says right bound. When I move right, I need to move right of my 0, but I don't want to move so far right that I pass up the other 0. So I can just move right just a little bit. Then I hit enter, and then I don't guess. I just hit enter one more time. And it tells me negative 1.6, 0. And then I need to repeat that step 2 more times. So I'm going to go second trace, number 2 for 0. Now I want to make sure I'm to the left of my second x-intercept, but I need to be to the right of the first one I found. Then I hit enter. Then I need to move to the right of that one. And then I hit enter, and then enter one more time. And I now get negative 1, 0. And then to find the last one, I'll again go second trace, number 2. And now I move to the left of my last 0, hit enter, and then move to the right, hit enter one more time, and I get 0.6, 0. Okay, now to find my minimum, I'll go second trace, number 3. Now minimum, I have to make sure I'm going to the spot on the graph where it went down and curved and went back up, so I need to move leftward. Now my cursor's to the left of it, so I hit enter. Then it says right bound, so I move to the right of the minimum, but don't go so far right that I pass up the maximum. Then I hit enter, then I hit enter one more time, and I get negative 1.3, 0.37. And then to do the maximum, second calculate number 4. So I go to the right or left of it, hit enter, go to the right, hit enter, enter one more time. So it's at, on that one I see an E negative 7, so that lets me know it's really 0, 0, 2. So now graphing, I will graph my 0, 2, and then negative 1.6, 0 would be about there, negative 1, 0, and then 0.6, 0.
Gabriel Frame, you have a pickup item in the front office.
The negative 1.3, that's supposed to be negative 0.37. Okay, so negative 0.37 would be down here a little bit. And then 0, 2, which I already had graphed. And then from here, I could use the end behavior if I knew the highest power was even or the highest power was odd, and then a positive leading coefficient or negative leading coefficient. So if it's even and a positive leading coefficient, both ends of the graphs go up. If it's a negative leading coefficient, both ends go down. If the highest power is odd with a positive leading coefficient, the left end goes down and the right end goes up. And then if it's a negative, it just flips. So looking at my equation, the highest power was odd and the leading coefficient was negative. So odd and negative would let me know that I would expect to see the end behavior looking like that. So then my left end of the graph would go up, my right end of the graph would be going down, and then I connect through those points that I already had graphed. And then you can see that that matches pretty well with what the calculator showed.